All right, this is Math 2, Unit 1, Worksheet number 2, with some homework help, looking at numbers 7, 11, 12, 13, and 15 today. Your first set does begin with just identifying different types of angles. So all these things here, corresponding, alternate interior, you can use a Google search and find out what those all are on your own, or look at your notes from your classroom teacher if you would. Number 7, we'll start down here for this one. Number 7 wants you to find the values of x, y, and z, using these values here for n and p. So we're going to have to do a little bit of plugging in some values to find out what these variables x, y, and z are supposed to be. So the first thing I'm going to look at here is I'm going to notice that I'm going to do this way. I'm going to go that this combination of angles, these two right here, this x and this negative 2n plus p, when I add those up, they should total 180 degrees because the two angles together are supplementary. So I'm going to rewrite that first of all. And when I rewrite that, what I rewrite it as is I'm going to write down that I have an x, because that's this one here. And if I add to it the negative 2n plus p for that piece right here, those things combined should equal 180 degrees. Alright, so that's how I start. So now what I'll do is I'll take my values here. P is 12, so I can put that into that spot. And N is negative 50, so I could put that in that spot here. So I have x plus, and I have a negative 2 times a negative 50 plus, and P is 12, equals 180. And so x is going to be plus negative 2 times a negative 50 is a positive 100, plus 12 equals 180. Combine those together and I have x plus 112 equals 180. Subtract 112 from both sides. And we have x is equal to 68 degrees. So that's my first part there. Now if x is equal to 68 degrees, what I also can notice here is that these here, this here, the x and the z are alternate interior angles, which means they're going to equal each other. So x is going to equal z. So I can automatically go ahead and drop that in there and say that z is 68 degrees as well. And what's left then is to find out what the value of y would be. Now the value of y, if we take a look at my chart here, I'll erase that just so you can see, y and x form a supplementary angle again, correct? So because y and x are supplementary, that means that x plus y equals 180 degrees, or in this case, if I said 180 minus the value of x, which was 68, I get 112 for what's left for the value of y. And that's number 7. All right, let's look at the next set. We're going to take a look at number 11 first of all. So here's number 11. I want to look at number 11 because I know when we see fractions, we often get a little bit nervous about, oh my goodness, it's a fraction, I don't want to deal with that. Please, something different. So here's our fraction here. We have 5/9 x plus 20 is the degrees there, and we have negative 1/3 x plus 16 for this one here. These angles are going to be considered corresponding angles, which means they are equal to each other. So I can set up the equation to say, let's make these two things equal, meaning I can say that 5/9 x plus 20 is equal to negative 1/3 x plus 16. So at this point here, I have an equation that I have to solve. I have to move things around to make this work out nicely. Okay, so to do that, what I'm going to do is I'm going to combine my like terms like I normally would. I'll start off by subtracting 20 from this side and subtracting 20 from this side. Okay, so that gives me a 5/9 x equals negative 1/3 x minus 4. So that's where I am so far, because 16 minus 20 is a negative 4. No problem there. Then I want to go ahead and move this over. So if I add 1/3 x to both sides, plus 1/3 x to both sides, now I have a fraction addition problem, right? So I have 5/9 plus 1/3. So if you think about this here, I'm going to go ahead and choose a space right here, all right? So 5/9, I have to have a common denominator in order to add up fractions. So here's a third. Fortunately, I know that 3 times 3 will give me 9, and I have a common denominator of a 9 at that point. Whatever I do to the bottom, I also need to do to the top. So I multiply this number by 3, and I have 3/9 instead of 1/3. It's the same thing, right? So 5 plus 3 is going to be equal to 8, and the denominator stays the same for 8/9 and x. So that's what this combined is going to be. I have 8/9 x, right? So let me move this over. I'm going to slide over here real quick. So we have 8/9 x is equal to our other number, which is still here, -4. I still want to get the x by itself, so I'm going to multiply by the reciprocal on both sides. 9/8, multiply this one by 9/8, okay? So the 9's cancel, becomes 1, 1, cancel 1, 1. So on this side I'm left with just the x, which is what I wanted. And over here, if I want to think about this as two fractions, I can reduce on the diagonal. So 1 4 there, and there are 2 4's in there. So I reduce, a 4 over 8 is really a half. I multiply across, -1 times 9 is -9, and 1 times 2 is 2. So I have -9 over 2 is the value of x. Just a strange little number, but that is actually what I got when I did it a couple times. So as far as I know, that's right. I have -9/2 is what the value of x is going to be. And that's all I'd ask you to do. If I wanted to check that, I could take this number here and I could plug it into my x values here, or plug it in here, and make sure that it works out. All right? Let's look at number 12 real quick. 12 is the interesting one, just because of how it's written. I wanted to share it with you real quick. Again, once again we have two angles that are going to be the same. They're going to be equal to each other. They're corresponding. So you're going to set it up as 9x plus 17 minus 3x equals 12 plus 4x plus 5. All right, no problem there. Let's combine our like terms. So we have a 9x and -3x. So this side we have 6x plus 17 equals, over here we have a 4x, and we can combine the 12 and the 5 plus 17. If I subtract 17 from both sides, the whole numbers go away, and I have 6x equals 4x. Okay? And 6x equals 4x. So what do we do here? Well, I can have subtract a 4x, subtract a 4x, and we have 2x equals 0. I can divide both sides by 2, and x is going to be equal to 0. It's really a strange answer, but that is the correct answer. What it's telling you is that the value of x is 0. If I plug 0 back into here, you end up with 0 plus 17 minus 0, so the top angle is 17 degrees. Okay, does this one match? Well, let's see. If I plug a 0 right in here, that becomes 0, and 12 plus 5 is 17 degrees. So it is a solution. X equals 0 is a solution for that problem right there. Let's look at a couple more here before we wrap it up. First of all, down the bottom, we're going to look here, just a little quick note. In this first one, which unfortunately we won't solve, but again we have two corresponding angles like we had before, which means they're going to equal each other. So in solving the value of x, you're going to set these equal to each other to find out what x is going to be. Down to number 16, we have two angles here that are going to be considered consecutive interior angles. So they are going to be adding up to, so if you call this A and call this B, well, A plus B would equal 180 degrees. So what you're going to want to do is add this to that and set it equal to 180 and solve for x. Same thing down to number 17. This plus this should equal 180. So let's do that one right here, number 15. We're going to say that x plus 84 plus 100, so this one plus this one, should equal 180 degrees. I shared this one with you because it's a little funky as well. We have x plus 184, sorry about that, equals 180. I subtract 184 from both sides, and we find out that x equals -4. That's the solution I got. It seems odd in some ways, but yet it is a solution, because if I plug this number back into here, we would say -4 plus 84 equals 80. And does 80 plus 100 equal 180? Well, it sure does, so we are okay. All right, that's it for today's lesson. Hope that helps you out a bit, and you have a great day.